This presentation is going to focus on modeling for systems thinking. There are two types of models for systems thinking. There are mental models and scientific models. Let's focus on mental models first. Mental models are informal representations and associations about the world or phenomena used to make decisions by individuals. Scientific models are formalized representations or explanations of the world or phenomena used to communicate or reason with. Mental models and scientific models are related and interact. So let's think about mental modeling first. We all have our own conceptions or ideas about fish, and we all have our own conceptions and ideas about ice cream. And we can think about fish and ice cream together in our own mental conceptions or representations or our mental models of how good we think fish ice cream might taste. So my mental model might be different from your mental model, which might be different from a third person's mental model. And we can all have our own individual mental models on how good we think fish ice cream might taste. So we can think about mental models as a way to integrate concepts within your own mind. So we can think about fish and we can think about ice cream, and we can integrate those two concepts to think about this new item, fish ice cream, and what we think we might feel about that flavor. Now we're going to talk about scientific models. So there are a few tools for systems thinking. We have qualitative approaches, semi-quantitative approaches, and quantitative approaches. Let's talk about qualitative approaches first. Qualitative approaches are tools such as qualitative scenarios envisioning, qualitative concept mapping, and rich pictures. And qualitative approaches are good for helping us think about problem identification. And this could be problem framing and identifying cause and effect relationships. Semi-quantitative approaches are tools such as cultural consensus, causal loop diagramming, participatory GIS and spatial analysis, role-playing games, and fuzzy cognitive mapping. Semi-quantitative approaches are particularly useful for data collection about the problem. This can be things like obtaining parameters and other important data that can be used for computational approaches. Quantitative approaches are tools such as agent-based modeling, system dynamic modeling, and Bayesian belief networks. These tools are particularly helpful for thinking about the analysis of problems, or asking questions that were unforeseen or what-if questions about the system dynamics. So all of these different tools for system thinking have different benefits and different trade-offs, thinking about what are your needs for exploring different types of problems. So some of the considerations you might want to take into account are, what are the time resources needed? What are some of the financial resources needed? Are there conceptual data you need to grapple with? Are there empirical data? Do we need to be training modelers? Do we need to be training stakeholders? What is the temporal resolution and what is the spatial resolution? So we can think about these trade-offs for some of the qualitative approaches that have low training needs, so it's fairly low barriers to entry, but they also have lower analytical capabilities. Whereas quantitative approaches require a lot of training at the get-go, but they also have high analytical capabilities. So as you're considering these different tools for systems thinking, it's important to think about the needs of the project or the problem, and then also what are the barriers that you need to consider for using these different types of tools. So we're going to talk a little bit about a tool from each of the following approaches: rich pictures, causal loop diagramming, and system dynamic modeling. Here we can see on the left-hand side the qualitative rich pictures model informing the semi-quantitative causal loop diagram, which then helps inform the fully quantitative model, system dynamic model. Here we can see the qualitative rich pictures model helps us understand and visualize the problem and the various components we believe to be informing the problem or the phenomena that we want to be exploring. And then using our rich pictures model, we can create a semi-quantitative model where we can use many of the components we've identified from our qualitative model and import that to a semi-quantitative model, and then use values and data from the literature to help us understand the quantitative relationships between those components that we've identified in the previous model. Then using the semi-quantitative model, we can then move on to a fully quantitative model where we can then create connections between each of the components that we have true values or that we have data or numbers from the literature or from research that we can define and then be able to run scenarios or make predictions about future dynamics of a system once we have each of those relationships defined by a quantitative value. So when we are thinking about the role of models in science and research and our broader understanding of systems, we have our individual researcher. Our researcher might have an internal representation or mental model about a system or phenomena, and using software such as Mental Modeler allows that researcher to take their internal conceptions or their internal mental models and formalize them and externalize them such that they can understand how they think the various pieces fit together. Then using our externalized mental model, the researcher can then collect data and run experiments to help further understand the relationships between the components and the system more broadly. And this is an iterative process where we run experiments and collect data based on our mental model, and then those data and experiments help inform our understanding of the mental model, and this cycle continues where the model informs the research and the research informs the model. And this feeds back to the researcher themselves as they're going through the iterative process of model refinement and data collection, such that the individual researcher ends up refining their individual mental model and their conceptions of the system based on this process. In the next video, we will be talking about fuzzy cognitive modeling.